Craig, why don't you talk to us about what you think are some of the important nuances to consider in a collision avoidance system in underground mines?
Yeah, thanks, Cynthia. There's a lot of conversations going on in the mining industry today about proximity detection, proximity awareness, collision avoidance, with our clients, with industry partners, with regulatory bodies, governments. And there's a lot of miscommunication about what is collision avoidance and what it's going to take to have a fail-safe system for collision avoidance that doesn't massively impact operations. And of course, that's our goal here, is to have something that's fail-safe and works within operations without impacting production or minimally impacting production. So it's a really important conversation. Thanks for the question. From my point of view, and from the conversations I'm having with the market, with our clients at Nutrax, there's really four tenets to a collision avoidance system. The first is that the system is peer-to-peer and can operate throughout the mine. The second is that it's mixed fleet compatible and that it works on all different kinds of brands and types of equipment. The third and a half is mixed, not mixed fleet, but measuring position accurately, being able to determine exactly, very precisely where equipment are, where they're moving. But not only their position, what are they doing? So the situational context becomes a very important part of that spatial understanding of where equipment are. And so those are the first three tenets. The fourth, again, I feel very strongly about this, having worked in these proximity detection systems for quite some time. With Nutrax is redundancy and ease of maintenance. Those are critical. Keeping equipment at a very high uptime is going to be very important to our clients in their journey towards collision avoidance.
Okay, great. So, you know what, why don't we dive a bit deeper in detail for those four tenets? Walk us through them.
Sure. Okay, great. Well, look, first of all, the first tenet was peer-to-peer. Unlike open pit mines, underground mines are a positioning system constrained environment. Systems that we count on surface, like GPS, on our phones, on our systems, our nav systems, just not available underground. Other systems that are commonly used in open pits, for example, electromagnetics, do work underground, but only in select cases. So there's a uniformity issue with how different types of detection and positioning systems, networks operate underground. Maybe even a third point is, while some mines have invested heavily in LTE and Wi-Fi, the vast majority have not. There just simply isn't high bandwidth network pervasive in underground mines, reaching all areas of an underground mine. So there's a positioning system challenge underground, and there's a network connectivity challenge underground. Plus other, again, dark, difficult environment to operate in, visible light challenges. Yeah. There's a lot of challenges underground that don't exist or don't exist to the same extent on the surface. So the sensor type and positioning that we use underground, the telemetry and the communication between vehicles, it absolutely must be peer-to-peer. That's the first tenet. So it has to be communication between vehicles for a collision avoidance system to work everywhere in the mine, to work when the networks go down, to work in difficult environments, easily in lit environments and dark environments. It's critical that the vehicles be able to communicate between each other and be able to do it from day one when the system goes live in all areas of the underground mine. So talking about the second tenet, if you want me to pause it so you can get the edit in. And so the second tenet is mixed fleet compatible. And I think that's immensely critical to all of our clients. There's not a single mine in the entire world underground that operates a single OEM. And that introduces a challenge of that you have to be able to work. That is, the collision avoidance system needs to be able to work uniformly across all types of equipment used on the underground mine. That includes light-duty vehicles like Toyotas, that includes drills, scissor lifts, graders, as well as prime movers in underground mines. And so in order, not only do they need to communicate amongst each other in a peer-to-peer format, but the system needs to work on all these different pieces of equipment. The system's going to need to be able to slow and stop these different pieces of equipment. And it's going to need to be able to do it in a consistent, reliable way built into the mine's processes, integrated with the mine's processes, in order for the collision avoidance system to be fail-safe and not interrupt production, which is what the objective here. The third tenet is, again, coming back to positioning and accuracy. That's the first part of the third tenet anyway. And so if you look at positioning and accuracy, there's a variety of ways to measure position and of different objects. One of the hot topics in the mining industry is time of flight. And again, Nutrax has gone down the path of introducing time of flight to our technology. We believe that's a big part of what we will be introducing and using for the future to come. All right, so the third tenet of a collision avoidance system for underground mines needs to accurately measure the position and location and movement of different vehicles underground and take into account situational context. So the first part of that is positioning accuracy. In order to operate an underground mine, we're going to need to be able to see around corners. We're going to need to be able to see equipment moving at long distances. And we're going to need to be able to very, very accurately determine different equipment at short distances. And probably even more importantly, pedestrian miners operating close to equipment and being able to detect those at ranges down to a sub-meter. So positioning accuracy is really important. As we've evolved and done our research at Nutrax, we've uncovered that there's a variety of different technologies out there that work in different situations. Time of flight is one of the types of technologies we've seen talked about in the industry. One of the interesting nuances of time of flight is there's a variety of different types of time of flight out there. What we've uncovered at Nutrax in our research is that, in fact, it's a combination of all these different sensor systems that's going to be required to deliver, one, functional safety. So if one system becomes unoperational for some reason, broken, rockfall, damaged equipment, poor maintenance, that there's a redundant system on top of that to make sure that the equipment still fail-safe in the collision avoidance system. And the second is that not all of those time-of-flight sensor systems work accurately at all distances. So we actually see a combination of different sensor systems providing redundancy and accuracy at all ranges. So we'll be building that positioning accuracy using multiple sensor systems into our technology. Now, taking into account using all those sensor systems, we're going to know where equipment are, what direction movement is taking place from. But we won't necessarily know, just from that data alone, whether or not we need to slow, stop, or take no action. And so situational context is a very important part of understanding that third tenet, the positioning accuracy and context. As an example, think about two haul trucks moving towards each other at 20 kilometers an hour. So it's a closing distance of 40 kilometers an hour. There's very little time to make a decision, especially if those trucks are loaded versus empty, on when to apply the brakes or shift gears to slow the equipment down. So we've actually got to be able to understand, is the truck loaded, what gear is it in, not only that, but what velocity it's moving in at, what distance is it, are the brakes overheated, potentially, is the truck climbing the hill or going downhill? All of these factors need to be understood in order for us to not only understand, are the equipment close to each other and moving towards each other or not, but do I need to apply the brakes sooner or later? So there's a tremendous amount of information that has to be gathered, and it has to be gathered at the equipment. It can't be gathered on the surface, and then the decision sent back. It needs to be on the equipment, decision made in real time and taken in real time by combining accurate positioning and situational context.
Wow. Great. Okay, so maybe walk us through the fourth and last one.
Well, interestingly, thanks. Interestingly, I actually discussed the fourth tenet in the third tenet. So the fourth tenet was redundancy. And so I'll add to that a little bit. Instead of just talking about redundancy through having multiple sensor systems, really, again, let's talk about ease of maintenance as part of that redundancy. So as I said in the third tenet, having numerous sensor systems interacting and working together provides coverage, even if there's one of the sensor systems is outside of its optimal range. So we've actually got a redundancy built in. If one of the outboard antennas is broken, the system will still operate -1. Now, if we get to the point where there's -2, in a difficult to maintain system where we require a technician to come to the vehicle, there's going to be a production impact of taking the equipment out. So when I talk about ease of maintenance, the system we're working on at Nutrax, and I believe in what the industry requires, is a system where components of the collision avoidance system can be replaced easily, quickly, and without a technician in place. So being able to replace an outboard sensor should it be hit by a rock or impacted by some other mechanism on an underground mine, it needs to be quick, be able to change quickly. So our system is designed to be very easy to maintain and redundant. And I suppose I'll couple those two together into the fourth tenet. And actually, if I think about it, Cynthia, that's probably 6 or 7 tenets. So I just like the sound of 4.
Great. Okay. Well, thanks so much for this